Okay, we are going to talk about Chapter 6 Important Components of Feedback Control Systems. For a general feedback control system, we have an input here and we need a reference sensor, and then we need a controller and then actuator. We may have a disturbance and plant to be controlled. Output. We need a sense the output value with the output sensor and then feedback to the input of the system. This is a general feedback control system. In a feedback control system, sensors are very important to sense various properties of the system, particularly the output of the plant. As you see here, we should measure the output value with the output sensor. A controller can then compare the output signal with the desired objective. At this point we have a desired objective, and then after the compared of the desired objective and output, the error signal will goes to the controller, and then actuator should drive the system, drive the plant according to the desired goal. Okay, so we can say sensors, actuators and the controller are the most important components of any system. In this chapter we focus on sensors, actuators and the actual brain of the control system, that is of course controller. We will start from the operational amplifiers. 6.1 operational amplifiers. Okay, operational amplifiers, or simply we say op-amps, offer a convenient way to build, implement or realize continuous data or S-domain transfer function. In control system, op-amps are often used to implement the controllers or compensators. Let's talk about the ideal op-amp. For the electrical circuit, we can give the op-amps as like that. In here we have a negative input and we have a positive input, and then the output we have E0. For the ideal input, we know that between the positive and negative terminal will be 0. Okay, so it means the voltage between the positive and negative terminals should be 0 for the ideal op-amp. And the other property of the ideal op-amp, the current should be 0 in here. Current should be 0. It means for us the input impedance is infinity. Okay, if you look to the input of this operational amplifiers, we can say the input impedance will infinite. The impedance seen looking into the output terminal is 0. If you look this circuit from the output, you will see the output impedance is 0. So we can say the output can be accepted as an ideal voltage source. Input and output relation for the ideal op-amp, we can say E0 is equal to A times E positive minus E negative. And as you know, A is accepted as infinite. Okay, for the ideal op-amp. So what can we do with the op-amps? Let's see this. For example, with this kind of circuit, what should we have at the output? Let's see now. With the same resistance here. This is a some operation with the op-amps. How? As I said before, the same voltage will be here and here for this circuit. Positive and negative terminal have the same voltage value. So we can say here 0 and 0. How can we write the equations for this circuit? At this point 0 we have, and we cannot have current for this path. In here we have a node, so we can write the node equation now. EA over R plus EB over R plus E0 over R will be 0. So in this equation we can get EA plus EB, but inverting, as you see. Okay, this is a sum operation with the op-amp. Maybe we can do the same operation with the non-inverting. Let's do this now. We have a op-amp here. With the same resistance, and for the positive terminal as you see we have two source with two resistance. So what can we do now? As you see here, at this point we have E0 over 2. So it means in here we have E0 over 2. So EA minus E0 over 2 divided by R plus EB minus E0 over 2 divided by R. It will be 0. For this circuit we can say E0 will be EA plus EB. What else? What can we do more? We can do a difference operation. As like that. Yes, at the output we have E0. At this point, as you see, in here we have a voltage division. So at this point we have EB over 2. So it means at this point we have EB over 2. So EA minus EB over 2 divided by R plus E0 minus EB over 2 divided by R will be 0. So what can we have now? EA minus EB is equal to minus E0, or E0 equal to EB minus EA. As you see, this is a difference operation. What can we do more?